This is a lecture for lesson 13. The first part of this lecture, we'll talk about interval notation and inequalities. We'll talk about how we use interval notation, the properties of inequalities, and then we will solve inequalities with one variable that are both simple and compound. When we're talking about inequalities, we're talking about these symbols less than or equal to, greater than, and greater than or equal to. And when we solve these inequalities, we can also talk about what is called interval notation. And each symbol has a corresponding parentheses or bracket that goes with it. So a quick little less than or equal to, greater than or equal to. If you have the equals to piece attached to it, the number that you have in your inequality is going to have a bracket. If you have just a less than or greater than, the number that is next to that inequality will be in a parentheses. The last part about this is going to be whether we are going to positive or negative infinity. If we are less than a number, we are going to negative infinity. If we are told we are greater than a number, we are going to positive infinity. Anytime you write infinity, the symbol that will go with infinity is the parentheses. So the only thing that can change to be a bracket is the number part, not the infinity. Let's take a look quick. Use interval notation to indicate all real numbers less than or equal to 6. The way I would write this in inequality form is all real numbers, so any number x less than or equal to 6. Less than or equal to means I'm going to go from negative infinity up to 6. So this less than or equal to symbol is right here, negative infinity. The negative infinity gets the parentheses, and the symbol for less than or equal to is then going to be a squared bracket on the 6. That means we include that value. Infinity is just a representation that the number keeps going, so we can't include it with a square bracket. Number 2, use interval notation to indicate all real numbers greater than 9. So all real numbers, x, any number greater than 9. So if I find the greater than symbol up here in my table, I have going to positive infinity, and we have a parentheses. So numbers that are greater than 9. So 9 is the smallest I can be. I cannot include it, so it's going to be a parentheses. And then I can go up to infinity, which also gets a parentheses. The next thing we're going to do is solve some basic inequalities. But before we do that, we do need to talk about a few rules. Just like equations, if I have something like a is less than b, what I can do is I can add the same term to both sides. So then a plus c has to be less than b plus c. And that makes sense, right? If we know 2 is less than 4, if I take 2 and add 5, that should still be less than 4 plus 5. Well, that's 7 has to be less than 9. Yes, that is still a true statement. Multiplication. We need to be careful with this here. There's 2 pieces to this, and this first one here, so let's think about it here. Let's use that same 2 and 4. 2 is less than 4. If I multiply by a number greater than 0, so let's say we want to multiply by 5. 2 times 5 is still less than 4 times 5. Well, let's check. 2 times 5 is 10. 4 times 5 is 20. Yes, 10 is less than 20. This does not hold true if you multiply by a number less than 0. Watch. If I start with 2 is less than 4, and I multiply both sides by a negative number, let's say 2 times negative 3 and 4 times negative 3. Well, 2 times negative 3 is negative 6. 4 times negative 3 is negative 12. Negative 6 is no longer less than negative 12. It is, in fact, greater than negative 12. So there is a special rule that if you multiply and or divide by a negative number, you have to flip the inequality symbol to maintain a true statement. Let me say that again. If you multiply or divide by a negative number, you must flip the inequality to maintain a true statement. Let's go ahead and do some basic solving then here. X minus 11 is less than 26. Can we solve for x? Well, sure. To get x by itself, I just need to add 11 to both sides, and I get x is now less than 36. I'm sorry, 37, not 36, 37. And that is inequality form. We can also put that in interval form. So less than 37 is going to be negative infinity, ending up at 37. Any number smaller than 37 is clearly going to go towards the negatives. Next, we have 2 is greater than or equal to x plus 14. Now, the x is on the other side. Doesn't matter. We can still do this as minus 14 on both sides. So I get negative 12 is greater than or equal to x. Now, if it helps you, you can flip this whole statement around. It's the other way. So x, the symbol was pointing to the x like that. So x is less than or equal to negative 12. If I want less than or equal to, it means I start at negative infinity. I'm going to end at negative 12, but that negative 12 gets the bracket piece. Next one, we have 9x is greater than or equal to 36. So if I want to get x by itself, I have to divide by 9. I'm going to divide both sides by 9. So divide by 9, divide by 9. And now we'll get x is greater than or equal to 4. That means 4 is the lowest I can be. Equals to means I square bracket it, and I can go up to infinity. And my last one here combines both pieces together. 8x minus 3 is less than 13. So we must first add 3 to both sides, giving me 8x is less than 16. And then I'm going to divide both sides by 8 to get x is less than 2. Less than means I'm going to start at negative infinity. I'm going to end at my number 2, and 2 is just a less than, so that will be a parentheses. The next two have a little bit more work involved, but no problem, we've solved linear equations, so we can solve these linear inequalities. Let me take a over to the side here. I have 8x plus 3 is greater than, on that side I need to distribute the 3 times the quantity 2x plus 1. 3 times 2x is 6x, 3 times 1 is 3. I will move the smaller of my x's, so 6x, I need to get rid of that by subtracting 6x. I have 2x plus 3 is greater than 3. And then to get this by itself, I need to subtract 3. 2x is greater than 0. And if I divide by 2, I still get 0. So x is greater than 0, meaning I'm going to start at 0 and go to positive infinity. And both of those are going to get parentheses. And if you ever need to, go back to that little table that I drew right at the beginning, and you can go between these two very easily. For B, we have some fractions here. 4x minus 3 all over 6 plus 2 is greater than or equal to 2x minus 1 all over 12. The way we solved these equations was multiplying by the common denominator. Well, 6 and 12, the common denominator would be 12, because if I multiply this first one, 6 by 2, that gives me 12. So I've got 12 here that I'm going to multiply everything through by. So if I multiply by 12 but divide by 6, I'm actually just multiplying by 2. That's the factor I'm missing, because this is 2 times 6 to make 12, which means I just need to do 2 times the numerator, 4x minus 3. Now this 2 must also be multiplied by 12. 2 times 12 is 24, greater than or equal to, and then this 12 is going to cancel out with the 12, so 2x minus 1. Next thing I'm going to do is distribute. 2 times 4x is 8x. 2 times negative 3 is negative 6. Plus 24 is greater than or equal to 2x minus 1. I can combine the number terms on my left. 8x will make plus 18 is greater than or equal to 2x minus 1. I'm going to move the 2x to the other side. It is currently positive 2x. So if I subtract 2x, it can come over. 6x plus 18 is greater than or equal to negative 1. I now need to subtract 18 to move that to the other side. 6x is greater than or equal to negative 19. And to get x by itself, I'm dividing by a positive 6. When you divide by a positive, it does not change the sign. So we have x is greater than or equal to negative 19 sixths. Greater than or equal to means that I can go bigger than that number. So I'm going to start with negative 19 sixths and go up to positive infinity. Because the symbol next to the number has a equals to, that negative 19 sixths is going to have the square bracket. Infinity always gets a parentheses. Now we're going to solve what's called a compound inequality, which means two inequalities in one. The way we look at these is there's two options. We have a union type problem and we have an intersection type problem. Intersection means the variable piece that you have is in the middle here. So this is an intersection problem. The second one is an intersection problem. When you see the word or, that is going to represent union. Union meaning I'm going to have two completely separate groups of answers. Intersection, you'll see when we do this here, intersection is going to have one single range of values, where union is going to give me two separate groups of values. Working with A, we have 6 is less than x plus 5 is less than 11. So what I have here is I have three sections. I have a left, a middle, and a right. So whatever I do to any one part of it, I must do to the other two parts. The goal is to solve for x, which means I need to get rid of the plus 5. So if I subtract 5 in the middle, I must subtract 5 from the right and subtract 5 from the left. That leaves me with 1 is less than x is less than 6. And what that means is x is between 1 and 6. So my answer can be a number between 1 and 6, but I cannot include them, so I cannot use square brackets around the 1 or the 6. B, negative 8 is less than or equal to x over 2 minus 4 less than negative 3. So again, I have a middle section, and we're always going to do that addition or subtraction first. So to get rid of minus 4, I need to add 4. I'm going to add 4 in the middle. I must add 4 to both the left and the right. That will leave me with negative 4 is less than or equal to x is less than negative 1. Oops, I'm sorry, x over 2 is in the middle. Negative 4 less than or equal to x over 2 less than negative 1. Next, I need to get rid of that divided by 2. So what I need to do is multiply by 2 to all three of my sections. I have negative 8 is less than or equal to x is less than negative 2. So this one, x is between -8 and -2. So -8 to -2. The symbol next to the -8 is an equals to, so it gets the square bracket. The symbol next to the -2 is just a less than, so it is going to get a parentheses. When we look at C, we've got two completely separate problems. They tell me 2x minus 5 is less than or equal to -11, or 5x plus 1 is greater than or equal to 6. So let's work with the first one here. We will add 5 to both sides. I have 2x is less than or equal to -6. And then if I divide by 2, x is less than or equal to -3. Less than goes from -infinity up to my number, and then we get a square bracket because it's less than or equal to on the -3. Then we just solve the second part, 5x plus 1. So I'm going to subtract 1 to get rid of the plus 1. 5x is greater than or equal to 5. And then to solve for x, I'm going to divide by 5 and get x is greater than or equal to 1. This one says that x can be greater than or equal to 1, means I start at 1, and then I can go any number bigger than that to infinity. Infinity gets the parentheses. Less than or equal to 1 makes the square bracket on 1. The way we write the combined answer here is the one that starts at -infinity to -3. And then we put the little U symbol for union. And then write the next one, 1 to infinity. So basically, I can't use any number that's between -3 and 1. Neither of those will work because that's not included in my solution here. But you can see one solution, where x is between versus two pieces of a solution with the word or. How do these compound inequalities differ from simple inequalities? Well, what we have, whether you're looking at them as a combined 3 parts here or 2 separate pieces, it's really 2 inequalities. I could rewrite this first one as 6 is less than x plus 5, and then I could write x plus 5 is less than 11. So what I have to solve is 2 inequalities instead of just 1. And we talked about these words. So the word or, if you see it in your compound inequality, is a union of the sets. If you see the word and, that will be an intersection, and x will be in between two numbers. The last part of this section is going to talk about absolute value equations as well as absolute value inequalities. When we solve absolute value equations, we will have two answers. Here's why. If I take the absolute value of 5, I get 5. If I take the absolute value of -5, I also get 5. What that means is the inside part of the absolute value can be a positive result or it can be a negative result. What's inside of the absolute value? Make that clear. We will have two answers. Some things we need to do is isolate the absolute value first. We cannot go to our two problems until the absolute value is by itself. There can't be anything left outside of it. The only other thing we need to remember after we isolate and then make our two problems is that an absolute value of a number can never equal a negative number. There is no way. So if I isolate the absolute value and I get the absolute value of 2x plus 5 inside the bars equals negative 10. That is impossible. There's no way to take the absolute value of a number and get a negative as a result. So let's give some of these a try. In A, we have the absolute value of 4x minus 2 over 5 equals 1. The absolute value bars are already isolated. There's nothing outside saying multiply by this or subtract. So we can create our two problems. The way we do this is this entire inside 4x minus 2 over 5 can either get me 1, which I absolute value and get 1, or that can be negative 1, and then when I absolute value it, I get 1. So I have to solve both of these problems with the exact same steps. I need to get rid of that divided by 5. So I'm going to multiply both sides by 5. I get 4x minus 2 equals 5. The next thing I need to do is get rid of that minus 2. So I'm going to add 2 to both sides. And I get 4x equals 7. Now to get x by itself, divide by 4. X equals 7/4. That is my first potential answer. And I'm going to follow those same 3 steps of multiply by 5, add 2, and divide by 4 on this problem. So multiply by 5, we have 4x minus 2 equals negative 5. I'm going to add 2 to both sides. I have 4x equals, that's going to be negative 3. And now I need to divide by 4, so x equals negative 3/4. So the two answers for A are 7/4 and negative 3/4. Working with B, we have 2 times the absolute value of x plus 5 equals 12. So in this one, the absolute value is not isolated yet. There's a 2 outside. So I need to work with that first. In order to get rid of that, I'm just going to divide both sides by 2. And I have the absolute value of x plus 5 now equals 6. From here, I can now create my two problems. That inside result, x plus 5 either equals positive 6, so when I absolute value it, I get 6, or that x plus 5 inside here can sum to negative 6, so that when I absolute value it, I still get positive 6. The only thing I have to do is subtract 5 from both sides. So x equals 1, or x equals negative 11. I can double check that. 1 plus 5 is 6. The absolute value of 6 is 6, times by 2 is 12. Negative 11 plus 5 is negative 6. Absolute value of negative 6 is 6, times by 2 gives me 12. I'm going to bring C down here. We have the absolute value of 2x minus 1 equals the absolute value of 3x plus 5. Well, the absolute values are completely isolated on each side. There's nothing left. So I can go to 2x minus 1 equals 3x plus 5, or 2x minus 1 equals the opposite of 3x plus 5. So what I need to do here is I'm going to move my smaller x, so minus 2x from both sides. I have negative 1 equals x plus 5. And then if I subtract 5 from both sides, I get negative 6 equals x. The other one, 2x minus 1 equals the opposite of the other side, so negative 3x minus 5. For this one, I'm going to add 3x because negative 3x is smaller. I get 5x minus 1 equals negative 5. I can then add 1 to both sides. I get 5x equals negative 4. And if I divide by 5, x equals negative 4/5. So it should work for both of these if I plug them in back here. We can try this one here. 2 times negative 6 is negative 12. Minus 1 is negative 13. Absolute value of negative 13 is 13. So let's see if this other side gives me 13. 3 times negative 6 is negative 18. Add 5 is negative 13. Absolute value it, I get 13. Negative 4/5 is going to be a little more difficult to do mathematically without a calculator, but I promise if you were to check it, it does in fact work. Number 2, determine whether the following statement is true or false. The equation, the absolute value of x equals negative 6 gives us the solution x is 6 or negative 6. Well, if you remember the rule that I gave you up here, or if you just try to plug it in, is the absolute value of 6 equal to negative 6? No. Is the absolute value of negative 6 equal to negative 6? No. Why? We cannot have an absolute value equal a negative number. So no, this is false. Absolute value cannot equal a negative result.